Okay, so identifying intermediates in a reaction mechanism. This is something you've probably looked at before in Gen Chem 1 when you are balancing reactions that occur as multiple steps. So remember, an intermediate is formed at the end of one elementary step and then gets used up at the beginning of the next elementary step. So when we're looking at this in kinetics and we're writing rate laws for elementary steps, intermediates are important in terms of if your rate determining step contains an intermediate, you have to get it out of terms of that intermediate into just terms of concentration of reactants later. Anywho, so if I look at step 1, I see my products are dinitrogen monoxide and water. And then if I look at the beginning of step 2, I see my reactants are dihydrogen and dinitrogen monoxide. So it is that dinitrogen monoxide that is my intermediate. So this is always the key to balancing multi-step equations. The amount of intermediate that is required for the second step has to match the stoichiometric amount that is produced at the end of the first step. Now, as we can see here, it's 1-to-1, so stoichiometry is not going to be a problem for us today. So how do you add together reactions that happen in multiple steps? Well, you are just going to sum everything on the left-hand side of that reaction arrow is going to be a reactant in our overall reaction. And it's just like a mathematical equation. You're going to gather like terms and you are going to cancel anything that appears on both sides. So H2 plus 2NO gas plus H2, I'm going to tidy up in a minute, plus N2O gas. Okay, and then everything on the right-hand side of this equation. So that is going to be N2O gas plus H2O gas plus N2 gas plus H2O gas. So we can see we can simplify this quite a bit. So we can see our intermediate is going to cancel out on both sides. That is our N2O, right? That's having a plus 2x on both sides of the equal sign on equation. You're going to cancel it out. We can also see some like terms we can gather. To gather like terms, they have to be exactly the same formula and state of matter. So we can gather our hydrogens on the left side and we can gather our waters on the right side. So my overall equation is going to be 2H2 gas plus 2NO gas, forming, so those intermediates have cancelled, 2H2O gas plus N2 gas, and you can check that, and that should be beautifully balanced. Are there any intermediates? Yes, we found one. So the intermediate we found was, it's always going to be the thing that cancelled out, so N2O gas was our intermediate. Sometimes you could have more than one, okay? So I'm going to just do a quick little search. Come on. I know there's harder ones in here somewhere. Now it's not going to show me. Would you believe it? Give me a 3-step reaction. Why don't you, Alex? Come on. I know you've got it in you. Aha! All right, so let's just clear the drawings here real quick. So look, bromine is formed at the end of step 1 and used up at the beginning of step 2. That would be an intermediate here. And chlorine, sorry, is formed at the end of step 2 and used up at the beginning of step 1. Okay, so we've got 2 intermediates there. All right, so hopefully that is helpful for you and you kind of remember how to balance these kind of expressions from Gen Chem 1, and we are a bit more cognizant of what the meaning of an intermediate is.